The electron in the hydrogen atom first jumps from third excited state to the second excited state, and then from second excited state to the first excited state. Then the ratio of the wavelength lambda 1 is to lambda 2 emitted in the two cases is how much? Okay, that question is electron in the hydrogen atom first jumps from third excited state to the second excited state, and then second excited state to the first excited state. The ratio of the wavelength lambda 1 is to lambda 2 emitted in the two cases is how much? Okay, this question is neat and AIPMT question. Okay, so option D is correct. So because when the electron jumps from third excited state to the second excited state, okay, so jump from the third excited state to the second excited state. Here n1 is equal to 1, n2 is equal to 2. So 1 by lambda 1, in the first cases 1 by lambda 1 is equal to 1 by, so okay, third to the second excited, third excited state means 4, second excited means 3. So n1 is 1 by 3 square, n2 is 1 by 4 square. Okay, so we get 7 by 144 R. But when the electron jump from second excited state means 3 to the first excited state means 2. So 1 by lambda 2 is equal to R whole times 1 by 2 square minus 1 by 3 square. So we get 5 bar by 36. Okay, but we have to calculate the ratio, wavelength ratio lambda 1 is to lambda 2. We have to calculate wavelength ratio lambda 1 is to lambda 2 for the two cases. So lambda 1 by lambda 2 is equal to, so first condition 5 by 36 into reciprocal of this 144 by 7, so we get 20.7. so that means option D is correct. Okay, please like and subscribe my channel.